So hi everybody and welcome back to our C++ tutorial series for absolute beginners. This video 295, and in this video we continue with our value categories. In our last video we talked about expressions, and that expression has two independent properties, and this properties is a type and a value category, and we want to concentrate us on the value category. And when we read here a little bit more, we see the value category. There are three primary value categories: the PR value, the X value, and the L value. And when we read here even more, there are not only three, there are altogether 5 value categories, which we will talk not now. And the reason for that is it's a little bit still hard for us to understand what this means if I jump into that right now. Instead, to make it a little bit more easy, we are jumping to the history, and you can see here is a history. You can click on this, or you can just scroll down because it's here on the bottom. And when we go here to history, we will understand this a little bit more easy. And the reason for that is it will show you how this value category is invented and introduced. And let's go into it. It starts here with CPL, and when I let's read this together here. It says here the programming language CPL. I click on this CPL, it opens our Wikipedia site, and it says the CPL stands here for Combined Programming Language. And we are not reading this one. I want to show you here only one thing. It was made in the early 1960s. So this programming language is made in the 1960s. So we are talking about a programming language which was in the 1960s and was first to introduce value categories for expression. So this programming language has invented this or introduced these value categories for expressions. Important note here, these value categories will change a lot. They will change even the meaning and the namings. And you will see when I scroll here a little bit down, it starts here with CPL, then we have C, and then we are talking about C++, because this one is still not C++, and so on. This here will start with C++, then we have here C++ another version, and here another version. And again, you know what this means, I hope. When I scroll up here a little bit, you can see here the green numbers. This is the version. Why is this again so important? So you can see C++ is changing. It gets better and better. They try to fix errors, they extend it, they try to introduce libraries and all this kind of stuff, and they also change meaning. And here we will see they are changing the meaning of the value categories, and they extend it. Important here, like I said, here we start with the CPL. And here later we go to C++, how C++ is treating them. And one more side note, which is very important: when you have older code, let's say at the beginning as a beginner, it's not important because you are a beginner, but later when you go to advanced stuff and you are dealing, for example, you can see with another code which was written in C++ 11, for example, and when I scroll down, the C++ 11 rules are not exactly the same rules as, for example, C70. Why I'm saying that? That means for advanced people, not for beginners, they have to learn the old code too. Only if they are dealing with older code, for example, they have found on the internet or in old projects or whatever, wherever, code which was written 10 years, 20 years, or even more, before that, and they use the other standard. And if you learn right now the code for, let's say, 2023, and you are dealing with code 2011, for example, then you can make mistakes if you are not learning their standards. And you will see what I mean when we go here through the history, because the meaning of value expression, this is just one example, is changing here, and then you will see what I mean. All right, let's continue this. So first of all, we started here. It is a programming language, 1960s, introduced value categories for expressions. And then let's go here a little bit more. It says here all CPL expressions can be evaluated in right-hand mode, but only, and that's very important here, but only certain kinds of expressions are meaningful in left-hand mode. So we have to understand this sentence here, because this is our starting point more or less. So first of all, there are expressions. We know what expressions are. We learned this, but it says here, right hand, we can do everything, right? So, an important note here as well, at this time they had it very easy because they had only two value categories, right hand mode and left hand mode. And when we compare this to our mode today, or the value categories from today, we have here 5. They had only 2. Left hand mode was called there in this time will be our L value. They had just this left L. So you can see why they call all L for left hand mode. That comes, so they, when they say history, they mean L for left hand mode. And then there was this right hand mode, and careful, that will change a lot. Not this R value, what you see here. This becomes a new meaning. Actually, the R value, what they mean is more like this one, this PR value. But we will see this in a moment, a little bit more detail. Let's go back. So, but it's, so you can see they had it much more easier than, they had it easier than us. So, because there was just right and left. But let's watch this on an example to understand this also. Okay, theory, it's okay, but we have to see this a little bit in code. And here I have again a variable. I have here, what is that? Left hand mode. So this is the left side of the assignment operator. They call this one the left hand mode. This here they call the right hand mode. It's the right hand side of this assignment operator. So now let's watch it a little bit more in detail. What is C? C, is this an expression we learned? Yes, a variable name is an expression. Here a reminder, we go to the primary expressions. ID expressions including suitable declared unqualified identifiers. C is an identifier. Identifier means just a name for a variable. Yes, it is. And we can see, yes, this is a primary expression. So we have here an expression, a left-hand side expression here. All right. And is 0 an expression? Yes, it's in literal. And we learned literals are also expressions. And in this case, it is a right-hand side expression. And this sentence here says anyhow, okay, where is this history? Not here, sorry, here in this time. It says, okay, the right side is no problem for variables. For this one, the C can stay here. But on the left side here, there is a problem. What is the problem? They say it makes no sense for every expression. So let's try to figure out, wait a minute, which expression makes no sense. And we can see this even with these two expressions here. We figured out C is an expression, yes. This is an expression, yes. And let's try to figure out what they mean. So if I write here 0 equal, and now I have to find anything valid. Can I find anything valid here which makes sense? For example, 1 plus 1, it's an expression. And you can already see it gives an error and it says expression must be a modifiable L value. So this one here is not a suitable expression which can stay on the left hand side. Okay, we are understanding this. Okay, they mean not everything can stay here on the left hand side, but they are not specifying. We are not going too much in deep. We try just to understand. But on the other side, the C here, that can stay here on the left side, right? So when I make here C equal, let's write it equal 1 plus 1 plus 1. All right. So you can see there is no problem. It's on the left side. It's an expression, and I just make this other expression here, add it, and I can assign it. So so that's the meaning of this one. So there are some expressions you can put on the left side, not all. And that was so our distinct, the first thing what we note here. Okay, and we understand now. Okay, now I understand where it comes left hand side and right hand side a little bit, I hope. Let's read this a little bit more. It says then, when evaluating in right hand mode, so again, okay, This one is our right hand mode here or here. Let's see what happens. An expression is regarded as being a rule for the computation of a value. Okay, they just think it was a computation of a value. Interesting here again. This is definitely a computation of value. What is the meaning of this here? Must be not this one what I mean. This is of course also a computation, but interesting, this one here. Is this a computation of a value, the 0 here? What do you say? The answer is yes. Why? There we are computing nothing. No, but the 0 here is what? It is a literal, right? It's a literal. Literal is what? Literals are expressions. And the question is now, where is the evaluation? Where is the evaluation? We are not computing something. No, we are not computing something, but the compiler is computing something. It says this literal is a 0, and I make this 0 to a value 0. That's a little bit bad explained, but I hope you get what I mean. But because this, when I say literal, it's just a symbol. Think about this one. It's just a symbol. It's not the value 0, because the 0 can be this one is not the same like this one here, or you can say this one here is not the same like if I make here a character 0 or something like this one. This one must be deciphered by the compiler, and this is also considered at evaluating. So this one becomes here a value, later integer, because right now we are not sure if this is an integer or is this a double, and the compiler has its default settings and then it will evaluate this one. All right, something like that. I hope that makes a little bit sense. If not, no problem. We go on. So, okay. But they are saying an expression is regarded as being a rule of a computation of a value. Okay, the right hand value. And here, careful, this is the right side, is an evaluating of a value, but this R value here, careful, is not our R value, what we have here. So here, this is the R value for us, which we will learn in this value category. But their R value here is actually, I make a better example, is our PR value. So their R value from this time, 1960s, is our PR value, our pure R value. Because what they mean here is you can't put, we can't put a PR value, so this 0, for example, I can't put it here on the left side like before my example. Let's put it here back. It was the 0 equal 1 plus 1. I can't do this. This one here, it's not allowed. And this one, for example, you can't put this one here. Just so understanding. Okay, let's continue a little bit for the first part. And then let's read here, okay. When evaluating the left-hand mode, now we go to the left-hand mode, which is this part here, okay. Let's see what they are saying then. Left-hand mode, an expression is effectively given an address, and that's very important here too. So they started here to say the left-hand side, this one has an address. So what is the meaning of that? Wait a minute. Has this left-hand side no address? And here there is sometimes a confusing, because when we talk about computers, they say everything must have an address so that the compiler can access it or something. Careful. What they mean address is later, they are confusing it with registers and where they put in stack, and so this is not what we mean here with address. So what they mean here with address, so when we read this one, effectively gives an address. It gives an address, which means this address, which it gives by the compiler here, is accessible by the programmer. For example, I can access this value here. Now this C has an address, and I, as a programmer, I can access and use this address. And here a question. How we use address again? For what most time? References. The answer is references and pointers. For example, if I make here a pointer, let's make here a pointer, an int pointer as well. So let's call this just B. And I want you to point now to the C. What we do, we take the address of this value C, right? How was it with the address operator, and we write C. So you can see I can take the address, and that means this one here has an address. This one on the other side, when I compare to 0, how the hell I get now the address as a programmer, not the compiler. The compiler knows it's anywhere saved, anywhere in the register or anywhere there. It has also an address more or less so that the compiler know it. But as a programmer, how the hell I get this address of the 0? There is no access. So keep this in mind when they say it has effectively an address. It means not that the compiler don't know it. No, it means that the programmer can't access it. But I can use this, for example, the C, the left-hand side here. I can get the address. I can print out even the address if I want with this operator to see it, and I can use it. And the 0 here, if I try this one, I can't use it really. And we will see when we go on many other things as well with this kind of stuff. But I hope you understand this one. And then let's read here a little bit more together. It says here the left-hand value or L value, and you can see now the left-hand value, this one is called here L value, and that's nice because we are using this today also, but careful, we are using that today, but it is still changed a lot of meaning. We will see what, not that much, but it changed still meaning. We will see this in a moment when we go down. But I hope, that you understand it so far. Let's read the last part here. Left and right here stood for left of assignment, and you can see here assignment. It's very important. If they talked in this time about this assignment, let's say we have here an assignment operator, left side of the assignment, and here the right side of an assignment. That's why left, right of assignment. All right, so now you understand why everybody, when they talk about L value and R value, talking about historically about left and right. But now comes the problem. That counts not for today. So today, what we are going to learn, and that will change, this rule from there, it's not counting anymore. It's wrong. When we go on here, you will see that this rule, what we just learned, what is history, how it was introduced more or less, will change dramatically. And to talk about left-hand side, this left assignment, and right assignment, right side, is not right. That is the thing what you understand at first. And I think that's enough for this video. We'll continue here a little bit, but I want that you already read here a little bit on your own, this history, and you will see that will help you a lot, so that when I talk about the other parts, that you understand this a little bit easier and faster. And yeah, I think if you have any questions or anything else, write in the comment section like old time, and see you in the next video. Bye, good luck, and like all time, have fun and never give up.